Okay, we're now ready to tackle the factoring problems that are a little bit more involved, a little bit longer, and that's factoring things of the form ax squared plus bx plus c. We've already seen previously polynomials where there is a coefficient in front of the square term, but in all those problems we were able to just factor it out. These problems aren't that they're really more difficult than the other ones. We use a very similar process. But they are a little bit longer and more involved, and so that does tend to give some people a little bit of trouble. To begin here, we're going to look at an example of a multiplication problem where when we multiply it out, it will fit this format, and then we'll see if we can figure out how we can unravel it. So consider, for example, 2x plus 3 times 4x plus 5 as an example. And let's just go ahead and multiply that out, and you may want to take some time and do that on your own. When we multiply that out, 2x times 4x is 8x squared, 2x times 5 is 10x, 3 times 4 is 12x, 3 times 5 is 15. We can then combine our like terms. Okay, and so we have 8x squared, our 22x plus 15. And now our task is, how can we start with something like 8x plus 22x, 8x squared plus 22x plus 15, and then backtrack to get back to the original factors, 2x plus 3 and 4x plus 5. Well, first of all, it's not as simple as just looking at that 15 like we would have done in the problems before. You can see the 15 brings about the 3 and the 5, but 3 and 5 don't add up to be 22. So the first thing I want to note is that if we examine this when it was written with 4 terms, that we actually can work the problem out. 4 terms, we could do factoring by grouping, and we will actually do that in just a couple of minutes. But the problem is we normally won't be given the polynomial with 4 terms. It'll be given with only 3 terms. So our task becomes, how can we take this and rewrite it so that it has 4 terms? How do we know that we need to have a 10x and a 12x there? How do we know that we need to have a 10x and a 12x there? Yeah, so that becomes our primary question. Well, the key to answering that question is understanding that every 3-term polynomial of this format has a secret underlying number that is the key to factoring it. To see what that number is, consider here those coefficients 2, 3, 4, and 5. And let's just multiply those out. 2 times 3 times 4 times 5. And when we multiply those out, we get 120. Now that's not the only place that that number 120 shows up. If we look at the 8 and the 15, and we multiply those, we'll also get 120. And if we look at the 10 and the 12 and multiply those, we'll also get 120. And that's really the key to unlocking the polynomials, is noticing that the 2 numbers that we need in the middle have to multiply to be the same thing as the 2 outside numbers. And since we're given the 2 outside numbers, we can figure that out. And then we can work out figure out what the 2 middle numbers need to be, and then we can work the problem out. So those numbers there, that 120, is going to be the key to unlocking this polynomial, because that's what the 8 and the 15 multiply to be. And knowing that 120, then we can figure out that the 2 numbers that add to be 22 have to be 10 and 12, because those are the only numbers that add to be 22 that also multiply to be 120. And so that allows us to take our polynomial and write it with 4 terms. And once we have 4 terms, something should be registering now in the back of your mind. 4-term polynomials, we talked about a type of factoring to do, and that's factoring by grouping. So we can do our factoring by grouping once we have the 4 terms. And so 8 and 10, we can pull out a 2x out of both of those. And that would leave me with 4x plus 5. And when I come to the 12 and the 15, I can say, well, 3 will go into both. So that'll leave me with a 4x plus 5. All right, and then we can pull out the 4x plus 5 that's in both. And we have our 2x plus 3 left over. And we now have the result factored. Okay, so that's the process that we're going to be using. Kind of an introduction to the process. You may need to kind of go back and maybe look at this video a second time to really get the idea. In future videos, we're going to be looking at some more examples of factoring these kinds of polynomials.